Alrighty, so we are going to be going over questions from the Outcome 4 test review. So looking at the start here, we have that we're classifying the triangles as acute, right, or obtuse. So this is where we're going to have like c squared, we don't know, a squared plus b squared. So for number 1, we're choosing the biggest number to be our c. So we'll have 61 squared, we don't know, 11 squared plus 60 squared. When I square it, 61 squared is 3,721. We don't know, 121 plus 3,600. We're going to add the things on the right side. We get 3,721 here. We have 3,721 here. Oh, they're both 3,721. So they are equal. If they are equal, then it is a right triangle. If we had that c squared was less than, it would be acute. And, oh, well, that's kind of cut off. Oh, well. C squared is greater than, it would be obtuse. So, you're going to use that same setup in order to do 2 and 3. Okay. Well, let's keep going. Number, is this 4 or 5? 5 says a 20-foot ladder is placed against a building to reach a window that is 16 feet above the ground. How many feet away from the building is the bottom of the ladder? So we have this building, right? And the window is 16 feet above the ground. So whatever window we're reaching, maybe we say that's like here, that's 16 feet. And then it's a 20-foot ladder. So the ladder is the thing that's leaning, right? This is my ladder. It's leaning. This is 20 feet. We want to know how many feet away from the building is the bottom of the ladder. So that's this ground part here, right? That's like where that grass is. I'm going to call that X. And we're always going to assume that buildings are built at 90 degrees. So across from our 90 degrees is 20. So we'll have 20 squared is equal to x squared plus 16 squared. 20 squared is 400 equals x squared plus 16 squared is 256. We're going to subtract 256 from both sides, and we get 144 is equal to x squared. Once we have x squared by itself, we can go ahead and take the square root. Oh, there we go. And the square root of 144, this is a perfect square. We get x is equal to 12. So our answer is 12 feet. All right. The next one is very, very similar. You are given a picture for it. I would go ahead and probably put an X here instead of a question mark just to make your life easier. This one, your answer is a radical, right? It is just a square root. I think you end up getting like X is equal to the square root of 21. So know that that one doesn't break down. It's not nice, but make sure you still are showing your work. All right. Number 7 is the same type of thing where you're solving for the missing side. We know it's the same type of thing because you're given like 2 sides, we're finding a third side. The only difference on this one as opposed to the last 2 is that now x is our hypotenuse. So our setup is going to be like x squared is equal to 8 squared plus 14 squared. And then you will solve from there. Alrighty. Number 8. We are now dealing with a 45, 45, 90 triangle. I know this because I see that hang on. What was I doing? I see that one of these angles here is 45. There's a right angle. So that means this other angle also has to be 45 degrees. So I'm looking at that 45, 45 degree parent triangle, which is like 1, 1, square root 2. So we look in between, like that 45 and that 90 is a 1. So in between the 45 and the 90, we're dividing by 1. In this case, right, both of them are x. It's the same thing. Then in between the 45s, that hypotenuse is square root 2. So in between the 45s, the hypotenuse, we are dividing by square root 2. So we end up with the equation of x over 1 is equal to 14 over square root 2. Well, we can cross multiply, but for this one, we do have x over 1. If we have x over 1, x divided by 1 is just x. So we get x is equal to 14 over square root 2. This is technically an answer. We just don't like having the square root at the bottom. So we're going to fix that by multiplying the top and bottom by square root 2. And we get 14 square root 2 over square root of 2 times square root of 2 is the square root, right? This is the square root of 4, which is equal to 2. So that'd be 2. And I say, all right, can we divide? Sometimes we can, sometimes we can't. This case we can, we get 7 square root 2. So x is equal to 7 square root 2. Now, you may not have to rationalize every time. This time we did because our square root was at the bottom. But that's not always the case. Let's look at number 9. Number 9, we have a 30, 60, 90 degree triangle. We know that because there is a 90 degrees and there's a 30 degrees. So this one by default has to be 60. So looking at my 30, 60, 90 triangle, let's see, this is 1, square root 3, 2. In between the 90 and the 60 is a 1. So in between 90 and 60, I'm dividing by 1 there. Oh, that kind of is a mess. Oh well. It's 7 divided by 1. In between the 30 and the 90 is a square root of 3. So I'm looking in between the 30 and the 90 here. So y, I'm dividing y by square root of 3. And then last but not least, in between the 30 and the 60 is a 2, or the hypotenuse is a 2. So x divided by 2, because x is on the hypotenuse. And then we can set up our equations. As a reminder, we can only solve for one at a time. So to solve for x, I'll have x over 2 is equal to 7 over 1. We cross multiply. 1 times x is x. 2 times 7 is 14. We are done. Then for y, we have y over square root 3. We're still equaling it to 7 over 1. We cross multiply. We have y is equal to 7 square root 3. We are done. Alrighty, let's keep going. Okay. Use what you learned from these two to go ahead and solve 10 and 11. And then in number 13 is kind of funky. This one, because the two sides are the same, it is going to be a 45, 45, 90 triangle. All right, let's go to number 14 and look at some trig. So on number 14, we are given an angle. It is not 30, 60, 90. It is not 45, 45, 90, right? It's 64. So that means that we can't use those triangles from before. We're going to have to use trig. So I'm looking at the angle. We have this as our angle. We're going to label the hypotenuse, the adjacent, and the opposite. So the hypotenuse is across from the right angle. Adjacent means next to, so this is right next to the angle. And then we have opposite. Well, in this case, it looks like we are looking for the opposite and we're given the adjacent. So we're going to have to think about our SOHCAHTOA, right? That would be SOHCAHTOA. All right, well, we have opposite and adjacent. So that's tangent, right? O and A. So tangent of 64 is equal to opposite over adjacent. All right, we're going to put this over 1 and cross multiply. My recommendation is to take the 11 and put it on the outside. I just tend to make less mistakes when I do that. So it'll be 11 times tangent of 64 is equal to 1 times x, which is x. In my calculator, I am putting in 11 times tangent of 64. And it looks like I get 22.6. Right, it says nearest tenth, that's 1 decimal. So x is equal to 22.6. Alrighty. Let's go ahead and skip to number 16. So for number 16, again, we are given an angle and a side. And it's not a 30, 60, 90 or 45, 45, 90. It's 59 degrees. So we're going to label our hypotenuse. Adjacent means next to, and then opposite. Well, in this case, it looks like we are looking for the hypotenuse. We're given the opposite. O and H. Oh, that's going to be sine. So we will have sine of 59 degrees is equal to the opposite over the hypotenuse. All right, so this is a case where x is on the bottom. We're still going to put it over 1 and cross multiply, but there is going to be an extra step. So when we do that, we'll have x times sine of 59 is equal to 1 times 9 is 9. Then we're going to divide both sides by sine of 59. All right, this goes away, and we're left with x is equal to 9 over sine of 59. Right, in our calculator, it's just division. So we'll type in 9 divided by sine of 59, and I'm getting 10.5. X is equal to 10.5. Excellent. Okay. Well, let's go ahead and look at number 17. So for number 17, we are asked to find angle B. That means we need a label off of angle B. So we're given two sides, which means we can't just add everything up to 180. So let's see, we have our hypotenuse, adjacent means next to, and then opposite. In this case, we have the adjacent and the opposite. So we're thinking back to our SOHCAHTOA. O and A, that's the tangent, right? That's the TOA part. So we're going to have tangent of angle B is equal to opposite over adjacent. We're then going to use the inverse. B is equal to tangent inverse of 19 divided by 7. As a reminder, that is second tangent on your calculator. Type in 19 divided by 7. And it says to the nearest degree, right? So this is going to be a whole number. So B is equal to 70 degrees. All right. Let's do number 20. Number 20 asks us to find the smallest angle. Now, you'll notice that these side lengths all kind of look the same, especially like the 8 and the 15. We are still going to figure out which one is the smallest based on numbers. So numerically, 8 is the tiniest number. It is across, it's opposite of Z. So angle Z is going to be the smallest angle here. Okay, so let's see, this is our opposite based on angle Z. This is the hypotenuse, this is the adjacent. We have all three sides. we can use whatever trig we want, right? However, I think it's going to be easiest, well, actually, it really doesn't matter. However, we haven't used cosine, so let's just use cosine. So cosine, as a reminder, it's the c part, it's the adjacent over hypotenuse. So we're going to have cosine of z is equal to 15 over 17. We use the inverse. Z is equal to cosine inverse of 15 over 17. We type that into our calculator. As a reminder, it is second cosine, and then just 15 divided by 17. And moving over here just for room, it looks like z is equal to 28 degrees. Alrighty. Let's talk about solving some right triangles. Let's go ahead and actually look at number 22. Okay, so 22, we need to find, right, we need to find all three angles, all three sides. We're given some of them, and then this test review, like your test, will tell you which ones are left to find. It does not matter which order you go in. I'm just going to go in the order it tells us, right? It says J, then K, then Y, but it really shouldn't matter. So since we're starting with angle J, I'm going to label everything based on angle J. So here's the hypotenuse, here is the adjacent, and then the opposite. Because I'm finding an angle, I need actual sides. I need to know what the sides, or I need to have a number for the sides. Just like up here, right, we had cosine of angle Z was equal to number divided by number. There was no variable there. There's no X's or Y's or something like that. Same thing here, right, when we were finding that angle. So to find the angle, angle J, I need to use the ones that have actual numbers. So that's the hypotenuse and the adjacent. A and H is cosine. So cosine of angle J is equal to 8 over 22. We're going to use the inverse. J is equal to cosine inverse of 8 divided by 22. So second cosine, 8 divided by 22. And it says to round to the nearest degree. It's 68.67. So that rounds to 69 degrees. Now, we can redo this process to find angle K. Or we can say, hey, we know that angles in a triangle add to 180. So to find angle K, right, I could just do 180 minus the 90 degrees from angle L minus the 69 degrees from angle J. And let's see, that gives us 21 degrees. All right, last but not least, we need to find that missing side. So I'm going to erase just so I don't have to be looking at everything. All right, we're finding the missing side, which is Y. Well, we're given two sides. We're finding a missing side. This is the Pythagorean theorem. So we're going to have, let's see, our hypotenuse is 22. So 22 squared is equal to y squared plus 8 squared. 22 squared is 484, and then that equals y squared plus 64. We're going to subtract 64 from both sides. We get 420 is equal to y squared. And then we can take the square root. Now, when we are doing this problem and we are solving for a whole triangle, we're just going to get a decimal answer and round it to the nearest tenth. So in your calculator, that is second x squared. You should get that square root symbol. Then you can type in 420. and it's going to be about 20.5. It's like 20.4939. Awesome. Okay. All right, let's look a little bit at angles of elevation and depression. So number 24, a baseball fan is seated in the upper deck of a stadium 95 horizontal feet away from the home plate. All right, so you are going to wonder, wow, is she that great of a drawer? Yes, I am that great. I should have been an art teacher. I know. So here, that's the person in the stands. Here's home plate. Okay, it's great. The angle of depression to the field is 62 degrees. What is the height the fan is sitting? All right, so we know that this is 95. Let's try to redraw that. That looks weird. Okay, here we go. That's a little better. 95. The angle of depression is 62 degrees. This is where we have to be super careful and remember that the angle of depression is based off of a horizontal line. So what we're really saying is, hey, here's our horizontal line. This is 62 degrees. Well, that means that this is also 62 degrees because alternate interior angles are congruent. Or your angle of depression is going to be equal to your angle of elevation. So once I put the 62 degrees down here, I'm going to cross it off up here because otherwise I will accidentally use it as a side length and I don't want to do that. We are asked at what height is the fan sitting? That's going to be right here. That's our height. You know what? Let's be a little more specific. Let's call it H so we know we're solving for height. After that, it's just trig. We're saying, all right, well, we have an angle. We're labeling the hypotenuse, the adjacent, the opposite. Well, we're looking for the opposite. We have the adjacent. That means we're using tangent. So tangent of 62 is equal to H over 95. Put this over 1. Cross multiply. We get 95 tangent of 62 is equal to H. Let me type that in. Let's see, 95 tangent of 62. And I am getting that, it's just as near as 10th. So it's 178.7, and it looks like it's in feet. Alrighty. Okay. Last but not least, let's talk about drawing a right triangle based on this. So, we're given the following information about triangle cat. Draw and label the triangle correctly. So we are going to start just by creating a right triangle, right? That's all we've been dealing with. Pretend it looks better. All right, let's try one more time. There we go, slightly better. Okay, we are then going to label all our angles. So we have an angle T and an angle A, where we have the sine of angle T, tangent of angle A. Well, we can't take the sine or tangent of the right angle. So A and T have to be not the right angle. These could have been flipped, but they can't be the right angle. And then it's triangle cat, so the last one has to be C. Then we're going to decide, do we want to start with sine or tangent? Doesn't matter. I'm going to go with sine because it's listed first. So based on angle T, I'm going to label the hypotenuse, adjacent, and opposite. Okay, so sine is opposite over hypotenuse. So that means this is 5, the hypotenuse is 13. I think the easiest way to do the next thing is we're going to look here and we're going to say, which number have we not used? Well, we've used 5, right? We haven't used 12. So I'm going to go ahead and just put a 12 here. It will end up being opposite over adjacent based on angle A. But that's all you need. You don't have to leave if you don't want. Like, I don't care if you leave it the hypotenuse, opposite, and adjacent, but if it's confusing with the angle marks, you can erase it. But this is what your final triangle should look like. If you still have questions on the review, please reach out. We are here to help, right? We have flex every day, not every day. We have flex both Monday and Wednesday. We have access every day. We are here to help. Please reach out. Hope you're having a good day. Bye.